The world at first started seeing remarkable photos of the universe, got by the solid James Webb Space Telescope, JWST, shipped off by NASA. This forceful, but then again momentous, errand has upset how we could decipher the universe by sending back a movement of stunning new pictures. These most recent visuals have shocked specialists and fans the same, giving experiences that test existing theories and open up new areas of examination, dissimilar to anything we have at any point noticed. These photos offer us a brief investigate the most faraway and secretive areas of the universe, stretching the boundaries of human knowledge into odd spaces. Before we start, hit the like and subscribe buttons for more select news. The JWST, expected to be the replacement for the Hubble Space Telescope, has outperformed assumptions with its high-level infrared abilities. This allows it to peer deeper into the universe than any other instrument before it. While Hubble gave astonishing viewpoints on the universe in visible light, the James Webb Telescope basically works in the infrared range. This limit empowers it to cut through endless dust clouds and uncover the secrets of star formation, black holes, and early galaxy development. The telescope's most recent pictures have uncovered districts of the universe that were previously stowed away from us, offering new data about peculiarities that have long bewildered space experts. One of the most critical pictures returned by the JWST shows a region of space up until this point off that it returns to several 100 million years after the Big Bang. This period in cosmic history, known as the dark periods of the universe, has been largely covered in mystery. During this time, the first stars and galaxies began to form, and the universe started to emerge from its early-stage state. Interestingly, specialists are seeing proof of these earliest structures with wonderful clarity, permitting them to sort out the events that shaped the early universe. In these new pictures, thick billows of gas and dust, huge nurseries, can be seen bringing forth stars. These districts are among the absolute most brutal and tempestuous in the universe, where gravity orchestrates huge amounts of matter to ignite the nuclear reactions that form stars. The JWST has captured complicated subtleties of this process, showing stars in various phases of their development and offering a window into the life cycle of stars in a way that has never been possible before. By concentrating on these pictures, cosmologists can learn about the conditions under which stars are born and how these processes have evolved over billions of years. In addition to stellar nurseries, the James Webb Telescope has also captured pictures of far-off galaxies, many of which have never been seen before. These galaxies are so far away that their light has taken billions of years to reach us, meaning we are seeing them as they appeared when the universe was still in its infancy. The telescope's unrivaled resolution has uncovered complex structures inside these galaxies, including massive black holes at their centers and star clusters that are much older than our own Milky Way. These black holes are especially intriguing because they challenge our current understanding of how these objects form and evolve. Some of the black holes found in these pictures are much larger and more dynamic than expected for such an early stage in the universe's history. Theories about how black holes develop typically suggest that they begin as small, dense objects that slowly accumulate mass over time by consuming surrounding matter. However, the JWST data suggests that some black holes might have formed fully developed or undergone rapid growth, prompting astronomers to reconsider their models of black hole development. The pictures of these early galaxies also raise questions about how galaxies themselves form and evolve. Some of the galaxies seen by the JWST are surprisingly well organized, with defined spiral arms and central bulges, despite being so young in astronomical terms. This level of organization is remarkable, as it was previously believed that the early universe would be more chaotic and irregular in shape due to the violent processes involved in their formation. The discovery of these well-structured galaxies suggests that galaxy formation may have happened much more quickly than previously thought, which has significant implications for how we might interpret the early universe. The JWST has also provided a dazzling new perspective on one of the most mysterious objects in the universe: exoplanets. These are planets that orbit stars outside our solar system, and while many exoplanets have been discovered over the past few decades, we still have little understanding of their atmospheres and potential for supporting life. The James Webb Telescope's infrared capabilities have allowed scientists to study the chemical compositions of exoplanet atmospheres more closely than ever before. Some of the new pictures and data have revealed astonishing discoveries, including the presence of water vapor, methane, and other organic molecules on certain exoplanets. These discoveries are especially exciting because they bring us closer to answering one of the most significant questions in science. Are we alone in the universe? The presence of organic molecules in an exoplanet's atmosphere doesn't necessarily mean that life exists on these planets, but it suggests that the building blocks of life are more common in the universe than previously thought. These findings could eventually lead to the identification of habitable worlds beyond our solar system, potentially changing the way we think about life in the universe. The JWST's new pictures also provide valuable insights into the final stages of stellar life. The telescope has captured detailed views of supernova remnants, huge glowing clouds of gas and dust left behind after a star explodes. These remnants are not only beautiful but also scientifically significant, as they are the sites where many of the heavier elements in the universe are made. When a star goes supernova, it produces massive amounts of energy that fuse lighter elements like hydrogen and helium into heavier elements like carbon, oxygen, and iron. These elements are then spread across space, becoming part of new stars, planets, and eventually life itself. The James Webb Space Telescope's new pictures, which delve into the earliest sections of the universe's existence, have opened a window into a cosmic history we could scarcely fathom before. What makes these pictures especially moving isn't just their beauty, but their ability to uncover secrets of the universe that were once completely unreachable. These never-before-seen scenes of distant galaxies, nebulae, and massive structures are leading us to rethink what we assumed we knew about the universe. While the photos of distant galaxies and intriguing phenomena have captured the public imagination, one of the most shocking discoveries made by the JWST involves objects much closer to home: the outer reaches of our own solar system. The telescope's infrared sensors have been able to study the cold worlds at the edges of the planetary system, revealing new details about their composition and surface features. For example, the telescope captured a detailed image of Pluto's moon Charon, revealing a complex landscape of icy plains and mountain ranges that had previously been hidden from us. These observations of the outer solar system could help scientists understand the formation of planetary bodies in cold, distant regions of space, such as the Kuiper Belt, a vast region of space beyond Neptune that contains billions of icy objects. The JWST's ability to study these objects in detail could provide new insights into how planets form in the outer reaches of planetary systems, offering clues about how our own solar system came to be. Beyond individual discoveries, the James Webb Space Telescope is also helping to answer one of the biggest questions in cosmology. How did the universe evolve into its current state? By capturing images of galaxies, stars, and planets at different stages of development, the telescope is helping to build a timeline of cosmic history. These observations allow scientists to track the evolution of galaxies and stars over billions of years, providing a more complete picture of the universe's past, present, and future. One of the key revelations from the JWST's latest images is the realization that the universe's early years were much more active than previously thought. The photos show galaxies forming at a faster rate than expected, with intense bursts of star formation occurring in rapid succession. This challenges the long-held view that the early universe was relatively quiet and that galaxy formation occurred slowly over billions of years. Instead, it appears that the first few 100 million years after the Big Bang were a time of intense activity, with galaxies rapidly forming and evolving in ways that scientists are only just beginning to understand. The James Webb Space Telescope's ability to look so far back in time is largely due to its exceptional sensitivity. By observing in the infrared range, the telescope can detect the faintest traces of light that have traveled billions of light-years across space. This light, emitted by stars and galaxies in the early universe, has been stretched and redshifted over time as the universe expands. The JWST's ability to capture this ancient light allows scientists to see objects that are so far away that their light has taken nearly the entire age of the universe to reach us. In addition to looking deep into the past, the JWST is also providing a new perspective on the structure of the universe itself. The pictures reveal vast cosmic structures of dark matter and galaxies stretching across the universe like a spider web. These networks, shaped by the gravitational pull of dark matter, form the foundation of the universe's large-scale structure. By mapping these structures, scientists hope to better understand the role that dark matter plays in the formation and evolution of galaxies. The JWST's pictures provide a clearer view of these cosmic networks than ever before, offering new insights into the nature of dark matter and its impact on the universe. As the James Webb Space Telescope continues to send back new images, it is becoming increasingly clear that we are entering a new era of discovery in cosmology. The telescope's ability to see farther and more clearly than any previous instrument is revolutionizing our understanding of the universe, providing answers to long-standing questions while raising new ones. Each new image reveals a universe that is more intricate and beautiful than we ever imagined, full of mysteries that challenge our understanding of space, time, and the fundamental nature of reality. One of the most exciting aspects of these new discoveries is how they challenge existing models of cosmic evolution. For example, some of the galaxies seen by the JWST appear to be more mature than we expected for their age, suggesting that the processes that led to their formation may have occurred much more quickly than previously thought. Similarly, the behavior of distant black holes and the properties of exoplanet atmospheres are forcing scientists to reconsider their models of how these objects form and evolve. The future of the James Webb Space Telescope promises even more groundbreaking discoveries. As the telescope continues to observe the universe, scientists will be able to study a wide variety of massive phenomena, from the birth of stars to the formation of galaxies and the behavior of fascinating objects like black holes and neutron stars. The discoveries made by the JWST will likely shape our understanding of the universe for years to come, offering new insights into everything from the origins of life to the ultimate fate of the universe itself. As we continue to explore the depths of space, the James Webb Space Telescope will undoubtedly play a central role in answering some of the most profound questions in science. What is the nature of dark matter? How did the first stars and galaxies form? Is there life elsewhere in the universe? These are just a few of the questions that the JWST's observations may help us answer. In the near future, the telescope's ability to reveal the universe in unprecedented detail is opening a new chapter in the story of human discovery, one that promises to be as thrilling and extraordinary as any in our scientific history.